Hello students, now in this session I will explain question number 3 and I will give you some introduction part on question number 4 also of exercise 3.1 chapter 3 understanding quadrilateral. Now let's see what is there in question number 3. What is the sum of the measure of the angles of a convex quadrilateral? And what is the next part? Will this property hold if the quadrilateral is not convex? That is, if it is concave quadrilateral, will the property will remain same? So this is what we have to check. Fine. So there is two parts in this question. So let me just write the first part. This is the first part, and here we'll explain the second part. So let us divide it. Yes. Now the first part. Second part. Now let me draw one convex quadrilateral for all of you. See, this is a convex. We know that. What is a convex quadrilateral? The quadrilateral in which all the angles should be less than 180 degrees. Okay? And let me draw one concave. You see, concave. Isn't it? This is a concave. Sorry. The figure is little disturbed. Yes. Now let me name all the vertex. First of all, just make the vertex little prominent. Yes. Now name it. A, B, C and D. A, B, C and D. Okay, now this is convex quadrilateral. Quadrilateral. Okay, this is convex and this is concave quadrilateral. Okay. Now, so what we have to prove? That the sum of interior angles of a quadrilateral, of a convex quadrilateral, will be same with the concave quadrilateral. Fine. So how to find out the sum of interior angles of a convex quadrilateral? For that, what we have to do is that we have to draw one diagonal. We have studied about the diagonal, students, the line which joins the opposite vertex. So we'll just draw only one. We can draw another one also, but we'll not draw it here. Fine. So the line which joins the opposite vertex are called the diagonal. So why I have drawn this triangle? See, when I have drawn this diagonal, so I have divided this entire quadrilateral into two triangles, isn't it? See, this is one triangle, this is another triangle. Fine. So with the help of a sum of property of a triangle, we'll find out the sum of interior angles of a quadrilateral. Fine. So just watch me very carefully. What you have to write? Now from the figure, you have to just write it down. From the figure. Okay, just see the figure properly. From the figure, we infer that quadrilateral, okay, we infer that quadrilateral, what is the name of the quadrilateral? You will write it down. ABCD is formed into, or you can write by, two triangles. Isn't it? Two triangles. That is, we'll name the triangles also. Now, what is the name of the two triangles? ADC. So, triangle ADC. And what is the name of the another triangle? Triangle ABC. So, these are the two triangles. Once we have drawn the diagonal, isn't it? Now, we also know that the sum of interior angles of triangle is what? 180 degrees. So, we know that we write sum of interior angles of a triangle is what? 180 degrees. We all know this. Fine. So how many triangles are there? if this triangle is 180 degree, if all the angles is 180 degree, then there is another triangle is there. So this will also hold 180 degree only. So now what is the total sum then? What is the total sum? So that is, therefore, the total sum would be what? 180 degree plus 180 degree, that would be what? 360 degree. So that means the sum of the interior angles of a convex quadrilateral is 360 degree. Now we have to see that the same 360 degree will come for the concave quadrilateral or not. Okay? Same thing we'll do it here, students. We'll draw one diagonal here. See? One diagonal. Okay? Now when we have drawn the triangle, we have divided this concave quadrilateral into again two triangles, isn't it? So same thing we'll write it here. Same thing. Okay? So from the figure, we infer that quadrilateral, what is the name of this? ABCD is formed by two triangles, isn't it? And what are the name of the two triangles? That is ABD, triangle ABD, and what is the name of the other triangle? Triangle BBC. Fine. And we know that sum of interior angles of a triangle is what? 180 degree. So therefore the total sum would be what? How many triangles are there? 2. So total sum would be 180 degree plus 180 degree. That means 360 degree. So what we have learned? So we have learned that no matter if it is a convex quadrilateral or a concave quadrilateral, the sum of interior angle of a quadrilateral will always be equals to 360 degree. So how to conclude this sums? So at last we'll write, thus the property holds true if it is concave quadrilateral also. Okay, so this is how we'll conclude the sum. I hope all of you have understood this question number 3. Now let me give you some details on question number 4. Okay, it's very, very interesting. Now, as you all know that the sum of the interior angles of a triangle is what? 180 degree. Now, just now, in question number 3, we have learned that sum of interior angles of quadrilateral is what? 360 degree. Fine. But what if I want to know that what would be the sum of interior angles of a pentagon, that is a figure with 5 sides? What if I want to know what would be the sum of interior angles of hexagon, that is of 6 sides? What about 5 sides? What about 18 sides? What about 50 sides? How will I find it out? Now to answer this question, you need one formula. Fine. So today we are going to discuss on that formula by which you can easily find the sum of the interior angles of any polygon, students. Any polygon. No matter how many sides that polygon is carrying, you can find out the sum of interior angles of that polygon with this formula. What's this formula? So the formula is sum of interior angles of a polygon. I have not specified any polygon because it works out for any polygon. Okay, that is n minus 2 into 180 degree. So this is the formula, students. Very, very important formula. Okay. Now what is this n then? So we have to also write n stands for number of sides. So polygons will definitely carry some number of sides. So if you know the number of sides, then you can easily know the sum of interior angles of a polygon. Now let's check it. Okay, let's start with triangles. So in triangle, how many sides are there? 3. So now we'll check that whether the sum of interior angles of a triangle is 180 degree or not. Okay, so we'll use this formula. So for triangle we know that, we'll write it down, sum of interior angles of a triangle. Now we'll use this formula. What is n? N is 3. So we'll, in place of n, we'll write 3 minus 2 into 180 degree. So we'll first solve the bracket. 3 minus 2 is what? 1 into 180 degree. So it is coming 180 degree, isn't it? So sum of interior angles of a triangle is what? 180 degree. Now let's check for quadrilateral also. So in quadrilaterals, how many sides should be there? 4 sides, isn't it? So that would be sum of interior angle of a quadrilateral. Any type of quadrilateral, whether it is a square, rhombus, rectangle, parallelogram, trapezium, for any type of quadrilateral. So sum of interior angles of a quadrilateral would be what? Again we'll use the formula n minus 2. Now what is n? N is 4. So 4 minus 2 into 180 degree, that would be what? 2 into 180 degree, and see, we are getting 360 degree. Understood? So in my next video we'll discuss on the sum of interior angles for a different polygons. Okay students, that's it for now. So thank you so much. God bless you all. Take care and stay blessed.